welcome to G Fun Facts Online. Today we're talking about an enemy within. Imagine a cancer long associated with the perils of smoking and heavy drinking. Now picture its new face. Younger, healthier, and often a non-smoker. This isn't science fiction. It's the reality of oropharyngeal cancer, a cancer of the back of the throat, and its profile is undergoing a dramatic, viral-driven transformation. The culprit is a silent, ubiquitous virus, one that most sexually active people will encounter in their lifetime, the human papillomavirus, or HPV. Once known primarily as the cause of cervical cancer, HPV is now the driving force behind a staggering 60 to 70% of throat cancers in the United States. While other head and neck cancers are declining thanks to lower smoking rates, this specific HPV-positive cancer is on the rise, creating a strange and concerning paradox. So how does a common virus, which over 90% of people clear without issue, become a carcinogen? To understand this, we need to witness a molecular hijacking. The human papillomaviruses are a huge family of over 200 related viruses. Most are harmless, causing things like common warts. But about 14 types are classified as high risk, with 2 being particularly notorious, HPV-16 and HPV-18. These 2 are responsible for the vast majority of HPV-related cancers. For most of us, our immune system is a brilliant defense, clearing an HPV infection within about 2 years. But in a small, unlucky percentage of individuals, the virus persists. It doesn't just hang around. It embarks on a mission of cellular sabotage. The pivotal, dangerous step is when HPV integrates its own genetic material directly into our cell's DNA. Once inside, it unleashes its primary weapons, 2 oncoproteins named E6 and E7. Think of these as the masterminds of the viral takeover. The E6 protein has one main target, a crucial tumor suppressor known as p53. You might have heard p53 called the guardian of the genome. Its job is to act as a quality control manager. When a cell's DNA gets damaged, p53 hits the pause button on cell division, giving the cell time to make repairs. If the damage is too severe to fix, p53 triggers a process called apoptosis, essentially cellular self-destruction, to prevent a potentially cancerous cell from multiplying. The high-risk HPV-E6 oncoprotein effectively marks p53 for destruction, eliminating this vital safety checkpoint. With the guardian gone, cells with genetic errors are now free to divide and replicate, mistakes and all. Meanwhile, its partner in crime, the E7 oncoprotein, goes after another key security guard, the retinoblastoma protein, or PRB. The PRB protein acts as a brake on the cell cycle, preventing cells from proliferating uncontrollably. E7 binds to PRB and inactivates it. It's like cutting the brake lines on a car. With the brakes gone and the quality control manager eliminated, the cell is pushed into a state of perpetual division. The combined assault by E6 and E7 creates the perfect storm for cancer. The cell's own machinery is hijacked, forced to replicate endlessly, while ignoring all the stop signals that would normally be triggered by accumulating DNA damage. This uncontrolled growth is the very definition of cancer. This entire process, from initial infection to the formation of a malignant tumor, is a slow burn, taking anywhere from 5 to 20 years. This molecular hijacking wasn't discovered overnight. In fact, for decades, the cause of cervical cancer, one of the most common cancers in women worldwide, was a total mystery. Scientists suspected a sexually transmitted agent was involved, and for a while, the herpes simplex virus was the prime suspect. But the evidence just wasn't there. Then, in the 1970s, a German virologist named Harald zur Hausen proposed a different theory. He hypothesized that human papillomavirus, then really only known for causing benign genital warts, might be the real culprit. This idea was met with huge skepticism, but Hausen was undeterred. He and his team began a meticulous, arduous search for HPV DNA inside cervical cancer tumors. Their persistence paid off. In the early 1980s, they made a landmark discovery. They identified and cloned HPV-16 and HPV-18 from cancer biopsies, showing that the virus DNA was integrated into the cancer cell's genome and that the viral oncoproteins E6 and E7 were actively being expressed. It was the smoking gun, the molecular link between the virus and the cancer. In 2008, Harald Hausen was awarded the Nobel Prize for his work. He had fundamentally changed our understanding of cancer, proving that a common viral infection could be the direct cause of a major human cancer. His discovery didn't just solve the mystery of cervical cancer, it laid the scientific foundation for one of modern medicine's greatest triumphs. But we'll get to that in a moment. Hausen's work cracked the case for cervical cancer, but it turned out the virus wasn't done. As we mentioned, doctors began noticing that the same villain, HPV, was now the primary driver of cancers in the throat, specifically in the tonsils and the base of the tongue. The profile of these patients is strikingly different from the traditional throat cancer patient. They tend to be younger, are more likely to be male, and often don't have a history of heavy smoking or drinking. The primary mode of transmission for this oral HPV is believed to be through oral sex. The symptoms can be frustratingly subtle and easy to overlook. A persistent sore throat that won't go away, a painless lump in the neck, difficulty swallowing, or even just a muffled-sounding voice. Because the signs are so nonspecific, the cancer is often diagnosed at a more advanced stage, after it has already spread to the neck's lymph nodes. Despite this, there is a significant silver lining. Patients with HPV-positive throat cancer have a much better prognosis than those with tumors from other causes. Their cancers are far more responsive to treatment, like radiation and chemotherapy, which leads to significantly higher survival rates. This is partly because the patients are often younger and in better overall health, but also because of the unique biological nature of the tumors themselves. This better prognosis has led to a new and promising area of research: treatment, de-escalation. The side effects of standard radiation and chemotherapy can be debilitating, causing long-term difficulty with swallowing and severe dry mouth. So clinical trials are now investigating whether lower doses of radiation or less intensive chemotherapy could be just as effective for this specific group of patients, aiming to maintain the high cure rates while drastically improving their quality of life after treatment. Now, let's go back to that medical triumph I mentioned. The discovery that a virus causes cancer led to one of the most powerful and revolutionary ideas in medicine. If you can prevent the virus, you can prevent the cancer. This spurred a global effort. In the early 1990s, researchers in Australia, including Professor Ian Fraser and the late Dr. Jian Zhou, had a brilliant idea. They figured out how to create virus-like particles, or VLPs. These are essentially hollow shells of the HPV virus. They look identical to the real virus on the outside, so the immune system recognizes them, but they contain no viral DNA, making them completely non-infectious and harmless. Think of it as creating a perfect 3D wanted poster for the virus. Your immune system sees the VLP, learns what the enemy looks like, and produces a powerful antibody army, ready to neutralize the real virus if it ever shows up. This incredible technology led to the development of the HPV vaccines, Gardasil and Cervarix. Gardasil 9, the newest version, protects against the 9 HPV types responsible for the vast majority of related cancers. The impact has been remarkable. In countries like Australia, which rolled out a national vaccination program early, there's been a 77% decrease in the HPV types covered by the vaccine, along with a massive drop in precancerous cervical lesions. The World Health Organization is now pursuing a global strategy to eliminate cervical cancer as a public health problem, with widespread vaccination as its cornerstone. And crucially, while developed to stop cervical cancer, the vaccine's benefits extend much further. By protecting against high-risk HPV types, it helps prevent cancers of the anus, penis, vagina, vulva, and yes, the very oropharyngeal cancers that are on the rise. Prevention is our greatest weapon, but what about those who are already infected or have developed an HPV-related cancer? The fight doesn't stop with the preventative vaccine. Research is now focused on therapeutic strategies. Scientists are developing therapeutic vaccines, which are different. They don't prevent infection. They are designed to stimulate the immune system to recognize and attack cells that are already cancerous and expressing those HPV E6 and E7 proteins. Other cutting-edge approaches involve gene editing tools like CRISPR. The idea here is to use this technology like a molecular scalpel to go into cancer cells and directly disable the E6 and E7 genes, effectively switching off the engine of the cancer. And of course, there's immunotherapy, which unleashes the body's own immune system to fight cancer, a strategy that has already been approved for some advanced HPV-related cancers. The story of HPV and cancer is a stunning testament to scientific inquiry. It took us from a complete mystery to identifying a viral culprit, to understanding its every sinister move, and finally, to creating a vaccine that can stop it in its tracks. While this enemy within still poses a threat, the convergence of virology, oncology, and immunology has given us a powerful arsenal. With continued research and a global commitment to prevention, we have more hope than ever for a future where these cancers become a thing of the past. Thanks for tuning in to G Fun Facts Online.